Alright, so now we'll take a look at an example of one of the other strategies. So again, first thing is to locate or to identify which type of equation we're dealing with. Again, there are no double or half angle identities. There's no 2 theta. There's no theta over 2. So that's how we know there are none of those. Pythagorean identity, there's nothing clear with that. There is a sine squared, but I don't see any cosine squared, which is the Pythagorean identity that goes with it. Okay, there may be a greatest common factor, but let's take a look at this one, factoring a trinomial. And the reason that I know to look for that one is I see something squared, I see something to the first power, and I see a number. And that's the pattern of a trinomial. You might remember from dealing with quadratic equations, this is what a trinomial looks like. Something squared, something to the first power, and a number. And that's kind of like the pattern we have right here. So let's start by moving things all on the same side. We'll subtract a sine squared from both sides, and we'll subtract a 1. So when we do that, we have 0 is equal to 3 sine squared minus sine squared would be 2 sine squared. Okay, then we have that plus sign that's still there. And now we have that minus 1. So now this does actually look like a trinomial. And if you ever get confused by having trinomials mixed in with trig functions, here's how you can get around that. You could just factor this like it was variables. So instead of every time I see a sign here, instead of having the sign, I'll replace it with an x. So instead of having 2 sine squared, let's say we had 2x squared. Instead of having sine, 1 sine, let's just say we had 1x. And instead of having minus 1 will actually stay the same. So let's try and see if we can factor this right here. This is a trinomial that we can factor. So what will we have to do to get 2x squared? We'd have to do 2x times x, and in order to get them 1, we'd have to do 1 times 1. This is a negative 1, so that means one of these has to be positive, one of these has to be negative. Because this is positive 1, that's a plus 1, that means the 2 must be getting multiplied by the positive 1, and the 1x has to get multiplied by the negative 1. If you're not sure why that is, try it the other way and FOIL it, and you'll see that it won't work the other way. So let's just test this. 2x times x is 2x squared. 2x times 1 is plus 2x. That's going to be not minus x, so 2x minus x is just plus x, and then finally 1 times negative 1 is minus 1. So this does end up working, so let's apply that over here now. So I'm going to just put the equal 0 on the right side now. So 2x minus 1, that's the same as 2 sine minus 1. And then this x plus 1, remember we called x, we called that sine. So now we're ready to solve this, so we'll set each of these equal to 0, because either of those parentheses equaling 0 would cause the whole thing to be 0. And now on the left side we'll solve that by adding the 1 and then dividing by 2. So we get 2 sine theta equals 1. We'll divide by 2. So we get sine theta equals 1/2. Now remember from this table right here that hopefully has been memorized at this point, because it is going to show up in most of these, 30, 45, and 60. So if you remember this table, the question is where does sine equal, or sine of which angle is 1/2, and it's this one right here. It's the sine of 30 degrees. So that means one of our solutions is 30 degrees, but the steps up above, so we have to use the unit circle to find the other solution. So remember, sine right here, sine is coming out to be positive 1/2, and there are 2 places where that happens. One of them is in the first quadrant, and that's right here, 30 degrees. Sine is the y coordinate, so y equals 1/2 right there. Remember, there's another place over here in this quadrant where sine is also equal to 1/2, where the y is also equal to 1/2, and that's this reference angle of 30. So the question is, what is this big angle right here that has a reference of 30? And that would be 180 minus 30, which is our second angle. That's 150 degrees. So there's our second solution. This one, the other side is actually even easier to do, because we'll get sine equals -1. And remember, sine is the y coordinate. This blue dot that I'm drawing is the only place where y is equal to -1, and that blue dot occurs at 270 degrees. So we have 3 solutions, 30, 150, and 270, to solve that equation.